talk about scaling the L1. This is a pretty hot button topic for some people, so I'll just get into it. I am Erin Grasmick. I've been working at Parity for more than 6 years, and I've been in the blockchain space for more than that. I have a computer science degree from UW-Madison. My focus was distributed systems and job schedulers, which is, a way to get into blockchain, I guess. I've done a lot of testnet work, thousands of node deployments, but now I've been thinking like higher up the stack and more about like how blockchains work, like systems engineering, systems design, and things like that. In this talk, I'd like to cover understanding each other. Like we should be like friendly to other blockchains, I think. Like look at other people's approaches, take learnings from other chains, and take a deeper look at technologies that we're building and take the best bits of all of them and put them together. I'd like also to address like premium block space. So this is something interesting that people talk about sometimes when referring to the Ethereum L1. And I'd also like to talk about new approaches that we can take to maybe combine some technologies. Okay, so let's start. Why do we even care about this? People congregate towards like believing a certain set of trade-offs is correct, and there's like a huge tribalism about this, like in blockchain. It's been like a hugely hot button topic, not only in the Ethereum community, but also in like Solana, whatever, Polkadot. Why do we care so much about scaling? Why do we care so much about how scaling is implemented? Like, why are people so divided over this? Like, the block space wars are still ongoing. There's a belief that like a huge supply of block space can like revolutionize the apps and the use cases that can be built on blockchain. And like choosing one of these directions means like you have to commit to that, and you have to really undertake these massive engineering problems that arise by like the choice of scaling that you have. So like the modern scaling landscape today, like monolithic, scales with hardware. It's fast, which is good. It's synchronous, which is like what a lot of people want for DeFi. But like it's potentially centralizing because of these hardware like hardware requirements, and it has like definite limits because of like the internet, like the speed of light, the speed of whatever, speed of CPUs, and it gets expensive. So like it's definitely a centralizing factor. But the rollup roadmap, it's expressive, programmable. L2s can be fast, scales out to like the capacity that the L1 can actually take, like blobs and things like that. But there's so many multi-sigs now for L2s, and like this is also centralizing. And there's like single companies running rollups, and you don't really know how that's going to end up, like if they're going to decentralize or not. And you also have fragmented liquidity and users, and this is kind of like a bad state. So why would you scale vertically in the first place? Like obviously Ethereum is not doing this. But I want to like help us like understand a little bit like why someone would choose this approach. Hardware is always improving, so like, it might be more expensive to run validators, but like that hardware is always going to get better. So if you write software that improves with the hardware, that you're going to keep scaling, and you might not even have to change your code. A single shared state makes mental load for developers and users easy. Like you don't have to really think about what chain you're on, like where you're going, like what chain you're connecting to, anything like this. It really simplifies the tooling and interfaces for these types of chains because you just have one chain. And there's one chain to rule them all. The bad part is it does really introduce a different set of challenges. Like hardware and physical limitations are insurmountable, like the speed of light, like I said. And one machine is faster than many. So this is something that we're seeing more and more today with like Solana forks and things like that, where like people just want to co-locate nodes together and actually re-centralize previously decentralized chains. Like I think there's like a fork of Solana right now that's actually trying to co-locate validators in data centers just to make it faster. And that's kind of ridiculous. It's like going backwards, right? So again, one chain to rule them all, but in a bad way. So why do we scale via rollups? It's like a proven design, Like Ethereum has been going for a very long time. It's worked. There's a ton of engineering and research going into this. It allows developers to build exactly what they want. It's very expressive, programmable, and it scales out a lot. You can have, Ethereum has, 100 plus rollups now, and it's, working pretty well. And there's fewer centralizing forces due to lower hardware requirements. So you can have pretty low-powered validators and still scale in this way. But it introduces a massive amount of user and liquidity fragmentation, and there's a ton of, again, time, engineering, money, and effort trying to fix this issue today. It's a difficult paradigm for interface development. We've seen this in Polkadot quite a bit, where we want to present the chain as one network and to the user, but it's really difficult to help developers understand this. And I think this is also happening in Ethereum now, where you just want to have one thing, and the user might not even need to know what chain they're on with intents and things like that. So interoperability is a core problem of this, and it continues to be even in chains with Polkadot, where interoperability is built in from the start. It's still a little bit more painful. It does introduce friction, and another issue is economics. So I'll get into this a little bit more, maybe later. But the gist of it is that the economics of the relay chain, or the relay chain, or the beacon chain, I should say, needs to be balanced with the L2's growth. So we're seeing this as an issue where people are worried about the value accrual of the host chain token, like the L1 token. Because the L1 needs to have a strong token in order to back all of the rollups because of economic security. But the value accrual of the L1 token is maybe not straightforward if you have a bunch of rollups that are not using the L1's token as a gas token or aren't really paying the L1 that much for block space and security. So this is kind of an unsolved problem, and I think one of the most interesting things about the rollup approach. And each rollup doesn't have visibility into larger system. There's no big shared layer that they can connect to and interoperate within. Does it even matter? This is a good question. Maybe monolithic is enough for today. We see that both of these approaches are viable. We have monolithic chains doing well. We have rollup chains doing well. But we do want world-scale, future-proof blockchains. And do we want to scale with hardware, or do we want to scale in spite of hardware? We don't necessarily want to rely on hardware scaling forever, because we will hit these limitations that I talked about. And more supply of block space likely equals more demand over time. So if we see an explosion of demand for block space, it's likely that we're going to run out if we don't continue to scale. And I don't think that monolithic scaling can get us there. So really what we need is an additive system where larger networks is more capacity instead of having smaller networks that are just faster because they're small. So I want to talk about blobs a little bit as well. More is better, but more expensive. So rollups on Ethereum post blobs in differing frequencies, and this basically affects how it affects how much of the rollup you could roll back, and this is kind of weird to me as a Polkadot person. If you're interested in how the Polkadot model works, I think you should look into it. But certain rollups on Ethereum only post once a day or something like that. So their state routes only go there once a day. And blobs are pretty cheap most of the time. Obviously, there's a scaling, like a blob fee scaling mechanism. But a lot of people, when the fees go up, they actually post the blobs less often, just because they want controlled costs. And this is probably going to continue. I don't really see a way out of this, where chains will actually willingly pay more. There definitely are some that will willingly pay more, but I don't think all of them will do this. And it's it's hard to know how that's going to go. So there's also this concept of the L1 having premium block space, which means that it can't really compete against these rollups because they're always going to be cheaper due to the way that they're architected, right? So right now, Ethereum is more expensive, but people still like using the Ethereum L1 because it has this sort of premiumness to it, because Ethereum doesn't have fully shared security. And so if you want the security of the Ethereum L1, you use the L1, and you do pay more for that. But if it did have shared security and all things were equal, why would you pay more for the L1, right? Like you would just use an L2. So this is kind of another issue. But let's try something completely different. Let's combine the best bits of all of this. So let's combine native rollups, which inherit the full L1 security, with like STF verification, use decentralized sequencers, shift the L1 execution to a rollup. Casual users wouldn't even know about this if you did it properly. And make sure you have completely decentralized governance, so there's no further trust assumptions. So we're saying that, all of this, like all of the rollups, are going to be exactly as secure as the L1. And Polkadot does this. This is just for illustration. Polkadot basically has native rollups. Thank you, Sean, for the slides. Shared security as well. So Polkadot has completely shared security. And that's pretty unique. So like every single rollup is just as secure as the L1 on Polkadot. And so this is why we can do something like this, which is a radical vision, which actually Vitalik mentioned in a recent blog of his, where an extreme version of like taking the execution out of the L1 is you could actually move the EVM to a rollup in order to get this level of performance, increased performance. And I find this really interesting because this is something that Polkadot is actually doing today. So this kind of thing is going to be live this year on Polkadot. We are actually moving all of the execution and the user level stuff, like balances, staking, et cetera, onto a rollup. And so then we get all the performance benefits of a rollup, but we can just move it, and then the relay chain or the beacon chain just does nothing. All it does is consensus and secures all of the other rollups, but we get security and stuff for free. So I think this is like a really good way to do it, especially in a world where, like, when does all this stuff end? Like it's like a horrible like Jenga stack full of stuff. And like all of this stuff where you have to like put different things together in order to make things scale and interoperate and make them secure, I don't think is a good world. And like it's not a developer-friendly world, and it's not a user-friendly world. So yeah, I think that's about it.